Welcome to Smart Interview Prep channel. Today our topics is cooling tower interview question and answer. Let's start the video.
Question number 1. What is a cooling tower, and how does it work? Answer. A cooling tower is a heat rejection device that removes waste heat to the atmosphere through the cooling of a water stream. It achieves this through evaporative cooling, where a small portion of the water is evaporated, which removes heat and cools the rest of the water. Question number 2. What are the main types of cooling towers? Answer. Cooling towers are mainly classified into two types. O. Natural draft cooling towers. These use natural convection of air to circulate air through the tower. O. Mechanical draft cooling towers. These use fans to force or draw air through the tower. Question number 3. Explain the key components of a cooling tower. Answer. Key components include the basin, sump, fill media, drift eliminators, fan, for mechanical draft towers, and distribution system. The fill media enhances heat transfer by increasing water contact with air. Question number 4. What factors affect the performance of a cooling tower? Answer. Performance is influenced by ambient wet bulb temperature, water flow rate, air flow rate, fill type and condition, and the design of the tower. Question number 5. How is the efficiency of a cooling tower measured? Answer. Cooling tower efficiency is typically measured by the cooling tower approach, which is the difference between the cooling water temperature leaving the tower and the ambient wet bulb temperature. Question number 6. What are some common problems encountered with cooling towers? Answer. Problems can include scaling, due to mineral deposits, corrosion, biological growth, like algae and bacteria, and inefficiencies due to poor maintenance or improper operation. Question number 7. How do you prevent scaling and corrosion in cooling towers? Answer. Scaling can be prevented through water treatment such as chemical inhibitors or water softening. Corrosion prevention involves using corrosion-resistant materials and inhibitors. Question number 8. What are the safety considerations when operating or maintaining a cooling tower? Answer. Safety considerations include handling chemicals safely, preventing falls from heights, and ensuring proper ventilation and access to the tower. Question number 9. Explain the concept of drift in cooling towers. Answer. Drift is the entrainment of small droplets of water in the exhaust air leaving the tower. Drift eliminators are used to minimize this loss of water and chemicals. Question number 10. How does the design of a cooling tower impact its performance? Answer. Design factors such as the height of the tower, type and quality of fill media, fan size and efficiency, and the configuration of the water distribution system all affect the efficiency and effectiveness of a cooling tower. Question number 11. What are the key parameters to consider when selecting a cooling tower for a specific application? Answer. Key parameters include cooling load requirements, ambient conditions, such as wet bulb temperature and air quality, water quality, space constraints, and budget considerations. Question number 12. How does the water distribution system in a cooling tower impact its performance? Answer. The water distribution system ensures even distribution of water over the fill media, optimizing heat transfer efficiency. Poor distribution can lead to uneven cooling and reduced efficiency. Question number 13. Explain the concept of thermal performance in cooling towers. Answer. Thermal performance is typically measured by the cooling tower approach and range. Approach is the temperature difference between the cooled water and the ambient wet bulb temperature, while range is the temperature difference between the hot water entering the tower and the cooled water leaving it. Question number 14. What are some typical maintenance tasks required for cooling towers? Answer. Maintenance tasks include regular cleaning of fill media and drift eliminators, inspection and replacement of mechanical components, like fans and pumps, and monitoring water quality and chemical treatments. Question number 15. How do you calculate the water consumption of a cooling tower? Answer. Water consumption is calculated based on the evaporation rate, drift losses, and blowdown rate. It can be estimated using formulas that take into account these factors over a given period. Question number 16. What role does water treatment play in the operation of a cooling tower? Answer. Water treatment is crucial for preventing scaling, corrosion, and biological growth. It involves the use of chemicals to maintain water quality and protect tower components. Question number 17. What are the environmental impacts associated with cooling towers? Answer. Environmental impacts include water consumption, due to evaporation and blowdown, potential for chemical discharge into the environment, and noise pollution from fan operation. Question number 18. Describe the process of retrofitting a cooling tower for improved performance. Answer. Retrofitting may involve upgrading fill media to enhance heat transfer efficiency, installing more efficient fans, improving the water distribution system, or integrating new control systems for better operational management. Question number 19. What are the advantages and disadvantages of using natural draft cooling towers? Answer. Natural draft cooling towers have lower operating costs and energy consumption but require more space and are sensitive to wind conditions compared to mechanical draft towers. Question number 20. How can you optimize the energy efficiency of a cooling tower? Answer. Energy efficiency can be optimized by using variable speed drives for fans and pumps, optimizing the design and operation of the tower to minimize resistance to airflow, and integrating control systems that respond to real-time conditions. Question number 21. What are the different types of fill materials used in cooling towers, and how do they affect performance? Answer. Fill materials include splash fill, film fill, and others. They impact performance by increasing the surface area for heat transfer and controlling water distribution. Question number 22. Explain the concept of approach and range in the context of cooling towers. Answer. Approach is the temperature difference between the cooled water leaving the tower and the ambient wet bulb temperature. Range is the temperature difference between the hot water entering the tower and the cooled water leaving it. Question number 23. How does the operating temperature affect the efficiency of a cooling tower? Answer. Lower operating temperatures generally improve efficiency by reducing the approach, which means the cooled water temperature is closer to the ambient wet bulb temperature. Question number 24. What are some key considerations when designing the water distribution system of a cooling tower? Answer. Design considerations include achieving uniform water distribution over the fill media, minimizing pressure drop, ensuring proper drainage, and integrating control mechanisms for optimal water flow. Question number 25. What role do fans play in the operation of a mechanical draft cooling tower? Answer. Fans are crucial for drawing or pushing air through the tower to facilitate heat exchange. They are sized and operated to achieve the desired airflow rate for efficient cooling.
Thanks for watching our video. Hope our video helps you in interview session and your knowledge upgradation. Wait for our next video. Till then, bye bye friends.